A while back, I shipped a change to a support agent, a clunky system prompt I rewrote tighter. The replies came back cleaner and more human, so I shipped it on a Friday. The next week, a compliance reviewer pulled a sample of the outgoing emails. On a slice of refund replies, the new version had quietly dropped a disclaimer we were legally required to send. The tools worked, the model was fine, the prompt read beautifully, and it failed anyway. The only thing between me and that mistake was my own eyeballs, and I'd looked at maybe a handful of examples. So here is the question this episode answers. How do you know a change made the system better, not just different? The discipline that answers it is evaluation, Evals for short, and it's a whole scored domain on the professional architect exam. Foundations ask whether you could build the thing. This asks whether you can prove it's ready and defend that call to someone who wasn't in the room. I wrote out 25 real support tickets from our history, the messy edge cases that had burned us before. Next to each one, I wrote what a correct, compliant reply actually looks like. That list, real inputs paired with known good answers, is an eval set, and the careful version has a name, the golden set. Writing it was boring and it took an afternoon, but curating that set is the method, not some clever grading script. Anthropic's own eval guidance says the same. A small set drawn from real failures is a great place to start. Once that set exists, is the new version better becomes a number you can read, not a feeling. At architect altitude, 5 things are worth putting a number on, and you should name them cold. Accuracy, did it get the answer right? Latency, how long it took, because a correct answer that lands too late can still fail the user. Cost, what that answer burned in tokens at the scale you actually run. Safety, whether the output stays inside the lines, so it doesn't leak private data or promise what you can't deliver. And security, whether a malicious input can push the system off its rails, and whether it holds when one does. Most teams treat accuracy as the real metric and safety as a box to tick later. But safety and security are first-class metrics, each with its own cases and its own pass line. My disclaimer was a safety requirement. I had no safety eval, so I was blind where it had legal teeth. You grade an answer 3 ways, and a strong eval uses all 3 on purpose. First, a code check, plain deterministic code that reads the output and decides pass or fail. It's cheap and never drifts, so lean on it wherever right and wrong is clear, like whether the reply contained the disclaimer. Second, a model judge, another model scoring output against your written criteria for the fuzzy things code can't see like tone. The catch is a judge needs calibration, so you read its transcripts and confirm it agrees before you trust its scores. Third, a human read. Not every case, but to confirm the code and judge measure what you think. That's what mixed methodology means, and one grader for everything is the classic wrong answer. One last piece, what separates a real eval from a demo. Your set can't be only happy cases, it has to include the failures and adversarial inputs too. Sarcasm, a question full of typos, an input trying to make the model ignore its instructions. Here is the subtle one that catches good engineers. You test both where a behavior should happen and where it should not. If you only check that the agent answers refund questions, you'll never catch it answering the ones it should have refused. The failure mode for this whole domain has a name. Eval blindness, shipping a change with no set to catch the regression, then calling it looked better in testing a decision. Let me put this to work the way the exam will, with 3 questions. These are original, in the blueprint style, not real exam items, and we eliminate on principle. A team rewrote a financial reporting assistant's prompt for better tone. It read better in a demo, so they shipped it. Within days, analysts reported figures attributed to the wrong quarter. Before rolling out, how should they have decided whether the new prompt was an improvement? Add a few more tone examples to the prompt and redeploy. B. Route the harder reports to a larger model to raise accuracy. C. Run both versions against a curated set of real reports with known good answers, and ship only if accuracy holds. D. Turn on production logging so misattributions can be reviewed after they happen. A polishes the prompt without defining better. B. Reaches for a bigger model instead of a decision. Only C compares both versions before rollout, where D would only log the damage after, so C is correct. A healthcare intake assistant scores high on its accuracy eval, and leadership wants to ship this week. What's the strongest reason that eval isn't enough to approve release? A. Accuracy alone doesn't capture whether the system leaks protected health information which needs its own check and pass line. B. Raise the accuracy target to a perfect score before any healthcare system ships. C. Grade accuracy with a larger judge model so it's more trustworthy. D. Add a line to the system prompt telling the model never to reveal protected health information. B. Chases a flawless score that isn't the gap. C. Just buys a costlier grader for the same metric. D. Puts the safety rule in a prompt guidance, not a guarantee. So A. The missing safety metric is correct. An agent turns plain English into database queries, a large batch each release graded by a model judge on a subjective scale. The scores come back noisy run to run, so the team can't tell real regressions from grader noise. What's the better eval design here? Raise the judge model's temperature so it considers more possibilities. P. Replace the judge with a deterministic check. Run each query against a test database and compare the returned rows to the expected rows. C. Have a senior engineer hand grade every output before each release. D. Average several separate judge models together to smooth out the noise. Raises the wrong knob and makes the noise worse, and D. just piles more judges onto a broken grader. C is accurate but a human can't keep pace, so B wins run each query and compare the rows returned. So how do you know a change made the system better and not just different? Not from your gut, but from a golden set of the cases that matter, built before you ship. You measure the 5 things with safety and security first class, and you grade with a mix that keeps graders honest. And you fill the set with failures, so a regression gets caught before a customer catches it for you. The architect's move through this domain is one line: define what correct means before you argue how to reach it. Which opens the next problem. Once you can measure a system, you will want to change it and prove it helped. That's where A/B testing and cost optimization come in without breaking what already works.